time. Let's have a chat about the current hot topics in battery consulting.
Yeah, first of all, thanks for the talk. Good to see you again. It has been a while that we've been talking.
Yeah,
I think last time was a couple of years ago in the E-Lab, and now we meet here in Münster on this battery conference. So I feel super appropriate to talk about batteries again. I mean, the market is still Wild West. The technology kept developing in these couple of years. And I think if we keep this split, looking at both the market and the tech development, there's so much going on, and it's really worth talking about some of the details and how we see it as a consultancy. So I'm with Accenture at the moment, Industry X. So I'm not talking on behalf of the whole company, of course, but I can express to you my understanding and observations in the market and how we look at this development of this nascent battery industry ecosystem in Europe.
Yeah, with your expertise. And maybe you can elaborate quickly on your background so that people understand what your expertise, original expertise lies in, that you were trained in.
Yeah, so by training, I'm a material scientist. Did my PhD in Aachen at the RWTH, went into chemistry, and then as a postdoc, and that's the time where we met, I went to the Institute for Production Engineering. And that was a couple of years ago when especially the gigafactory boom in Europe was caused. So I made my jump into the world of the service providers. So joined a company in Aachen, started working on engineering and consulting services for the battery industry, and therefore currently focused on this mix between battery technology, market intelligence, and also helping our clients to ramp up this ecosystem. But then both with the eyes of a material scientist, a cell chemist, so to say, but also from like an industrial and engineering point of view.
Okay. So if we're talking about ramp up, where are we right now? Are we still on a steep incline, or what's the current status?
On an incline, I think that's the important message. We keep growing and the ecosystem is getting bigger. But is it steep? I think if we look back 4 to 5 years, this was probably the steepest we've seen in terms of announcement and also the vision that new cell manufacturers had for Europe especially. There was the announcement boom for the gigafactory projects. Every major European direction of the sky got plenty of gigafactories announced. And now a couple of years later, we've seen how many of these projects eventually started production or were cancelled. And I wouldn't call it steep at the moment, but we're still in a growing trend.
Okay. And how long do you expect this growth to proceed? So I think the year 2030 is always a hallmark where people plan with, saying like until then we have, I think in Europe it's 1 gigawatt hours as a stated capacity. Like many consulting firms talk about this or state this range of capacity. How do you see that, Accenture?
Yeah, in terms of numbers, very similar. We're also tracking this, and since you asked how long will we expect that growth, I think, of course, we look at forecast to 2030, and everyone working with batteries know the forecast never lasts very long. So, but from a general technology adoption and market development point of view, 2030 will be growth for sure, probably even solid double-digit growth for the whole battery ecosystem on the whole value chain. And then at some point, I think when technology adoption in the electric vehicles comes to a saturation level, then we might go to single digits, and then maybe over the 2030, 40, 50, we see a slowdown. But then if you look at recycling, for example, this will be coming with much of a delay that will also cause the battery industry to grow just further in the downstream with maybe 10, 20 years later than the cell manufacturing.
Yes, I understand. But the next 10 years are probably marked by upstream and downstream, and for the production itself, growth. How do you see upstream development? You mentioned in our discussion before that you expect upstream that many innovations will happen. Can you name some examples that showcase the current dynamics of the field?
The dynamics are the interesting part. So how I consider it is basically you start with an application that creates a demand and the appetite for the batteries and also battery development. So in our case in Europe, it's obviously the electric vehicles, especially in Germany. So we need EVs on the street. We have a net zero pathway ahead of us, and we need that technology. So this creates the demand for cells, and this worldwide is said to go to up to 7 terawatt hours globally. And then in Europe, let's say it's 20% of this global market. So we have a high demand for these battery cells to be produced here.
20% of the car market?
Of the global battery demand. Or let's say this could be a benchmark for the rough positioning of the European battery industry on a global scale.
So it's 20% Europe, then I think like 50% Asia, especially China, and then the rest goes to the US and other countries?
I think US is growing a bit steeper, and probably from us European perspective that could be wishful thinking that we actually managed to get up to 20% market share globally. We should look into these dynamics later. But coming back to the value chain question, so you have this application creating the demand.
Yes.
Then you have now what we've seen 5 years ago, the battery cell manufacturing coming, which is in my opinion the heart of the value chain, was just the technologically most complex thing to accomplish for us. And now with the cell manufacturing plants starting operations and growing their businesses, we need materials in Europe. And that's something it wasn't discussed a lot in the last couple of years, but we now see a lot of refineries coming, component producers, automotive suppliers
so to
shifting.
Understand this dynamic, because we have the bird's eye helicopter view right now. So there were these announcements, right, of all these gigafactories. Many of them are in the build phase right now, but some of them also got lost on the way. I think we should also mention that. Because all this announced capacity, I think there was like 2 terawatt hours of announced capacity, and now it's like 1 terawatt hour is more realistic, as far as I know. But I could look up that number afterwards. And so the material manufacturers, the refiners, the mining companies, they kind of waited until they knew exactly how the market will evolve. So they didn't take the risk right up front when they heard of the announcement of the factories, but it's kind of with a delay. I'm asking this question because at the moment where the gigafactories are all in place, let's mark the year 2030, we need materials, right? So the question now is the mining industry and the refining industry fast enough to catch up now so that they both, at the kickoff event, have their production volume in place?
Yeah.
Do you see an issue there, or do you think it will all fall together and the supply chain will be perfectly linked upstream and downstream?
Yeah, classical consulting answer, it depends. I think in this case it depends on the materials and which step of value creation you're looking at. Of course, the value chain and industry growth happens at different time scales, especially very much upstream in the mining business. It can take 10, 15 years from exploration to actually ramping up the production volumes.
But don't we see a bottleneck then?
We see and we are aware of the bottlenecks, for example with lithium, and we had supply bottlenecks for nickel. However, then the refining capacities, and that's technically not as challenging as cell manufacturing, and the setup times for the plants are significantly shorter than also the gigafactories.
So we can meet those kickoff deadlines.
Yeah. Interesting is, of course, the mining part. Like, we'll be able to get enough lithium out of the brines and mines in time. Of course, considering dynamics with like sodium-ion batteries, reducing that demand.
Considering the environmental restrictions that have to be met as well, not just overgoing them, which could limit, in my understanding, the adoption or the mining capacities. Do you see issues also on that end, or?
Partially. I mean, there's a lot of mining already going on, and I think we need to look at what the Chinese are doing at the moment, being in control of most of these materials. So this didn't seem to negatively affect their ability to use battery cells. In contrast, we rather see overcapacities in China right now. But coming back to, for example, the European ecosystem, with these gigafactories kind of nucleating the industry, suddenly these gigafactories are big enough to have professional supply chain management and more demand for local suppliers. And then companies coming laterally into the market, developing new components and materials, can in short time set up a business and a venture where they said it wasn't relevant for us before. Because we can set up a refinery in 2 to 3 years.
Okay.
And in the meantime, the gigafactories have done their 5 years.
6 years of setup time mostly, from start of construction.
For gigafactories, yeah, I would say it's healthy.
That order of magnitude. So I understand. So that is not an issue from the market perspective.
Similarly, allow me this comment, the recyclers, because why should they set up the recycling plants now other than strategical reasons to position themselves and push their brand in the market and win customers for relationship building? But the capacities are not yet that. So once the market really lifts off and the feedstock is coming to the recyclers, they will also set up and ramp up their plants. But now the forecasts are so uncertain that they say we wait a couple of years and then we keep monitoring the demand.
Okay, cool. All right, sounds good. So positive upwards trend, but we need to do our homework.
Yeah, we could say that the hype might be over, at least now, especially in cell manufacturing. There is more realism in the market with some of the, let's say, over-promising projects already dropping out of the market.
Yeah.
And now companies who secured more funding prove themselves to be worth that funding, hopefully. So now we will see who will be still on the market in a couple of years, and the consolidation wave is happening.
Yes, all that we talked about up to here was considering the lithium market, right? So lithium-ion batteries, may it be prismatic, round cell pouch, doesn't matter, but based on the lithium technology, NMC, LFP. How about all the others? So the technological innovation, all solid state, sodium-ion batteries. What else is on the horizon? So could you give us an overview of the current technological innovations that we see in the coming years?
Yeah, so there's plenty of innovations happening, and I think this conference is actually a good place to discuss this, because I was honored to host the materials sessions yesterday and a solid state session later today. And if you look at the periodic table, we know which materials are the good ones for the batteries. And now looking at material criticality, like we've seen with lithium, cobalt, we know which materials we want to avoid up front. So then you're considering...
Can you name them really quick?
Yeah, I mean, cobalt was an issue. We substituted, we kicked it out, and now nickel.
For nickel. Right?
Yeah, and now people say nickel could become the new cobalt. I mean, it's not where it is in terms of pricing as the cobalt, but considering ethical mining, availability, we can or have the ability to substitute nickel, replace it with cheaper manganese, maybe improving safety and not just squeeze out the last bit of energy density and range for the vehicles later.
Yes.
And then, go a bit back to manganese.
How about costs for those batteries then? What do you expect there?
I mean, we saw the high nickel trend for two reasons. One is the cost optimization, because nickel is simply cheaper than cobalt in the NMC triangle, basically. And the second aspect is tuning the specific energy, because you can get the higher energy out of the high nickel materials. So you had double the cost benefit from that. And now cost is, of course, the main driver, but we have plenty of low-cost chemistries coming into the market that are... but just by design, way better than NMC could be, but still a manganese pathway is super interesting.
In terms of production equipment and alternative designs, I want to talk about ASSB. Relevant? What do you think?
For sure. Solid-state batteries will be around all the time. They have been around, and they will stick around for a while, because I think market ramp-up is...
But will they ever take a significant market share? That's kind of the pressing question here.
I mean, what's significant? It depends on the applications. Like global battery market, I think 1% is already a good benchmark to achieve in the first place, especially given the immense ramp-up of LFP and NMC chemistries and sodium ion, of course.
So that would equate to, let's say, 1 terawatt hour in Europe in 2030 to 10 gigawatt hours.
Roughly, that's the size of a gigafactory, yeah. But but if you look application specific, let's say a premium high-end vehicle with maximum range, in this particular market, the solid-state battery could play a bigger role. But then you need to see what's the actual demand for this application, how many gigawatt hours are we talking. Hitting global economic scale, we're rather talking terawatt hours nowadays, but there will be so many applications coming that will demand for different chemistry, and solid state will have its part, just like sodium ion will play its part, and maybe even niche systems like magnesium ion batteries or aluminum could play a role in this system.
Okay. All right. Understand. So ASSB will take a role, and then the question is where? So if we compare the markets, Asia, US, Germany, or Europe, to be a little bit more broad, do you see different market trends? So this one, I know, for example, from Korea, they focus heavily on NMC rather than LFP. How do you see that, the global development? Again, like the helicopter perspective, if you should compare all of these.
I mean, looking in the past, you had basically, since lithium-ion batteries got industrialized, a few winning cell chemistries, and now it really got more diverse. For example, like the Koreans were coming then with the wave of consumer electronics, also pouch cells and NMC materials. And then the Chinese were adopting actually the LFP batteries, which we at some point said it will not be sufficient for electric vehicles, but they managed to engineer the cells so well that it's sufficient in terms of range and especially attractive in terms of cost.
Yes.
And this is what the Chinese were then really industrializing. So the hope is, of course, that Europe, North America will find their own way, a new technology, that we're ahead of the innovation cycles again and not try to catch up on a train, but really lead that market.
But is there really a technology available where we can foresee that? I don't see that, to be honest.
Yeah, that's the challenge. Like we have charted the electrochemical space. We know the materials out there. We know where the non-plus ultra is, which is lithium metal-based systems, usually found in maybe solid-state cells. And simply because out of lithium metal you could get the maximum voltage and specific capacity out of that electrode. I was researching lithium oxygen batteries 10 years ago in Silicon Valley. It was considered the holy grail, solving the range anxiety. However, from a chemical point of view, the lithium metal, it could not be tamed, especially not in a conversion type battery. The intercalation type systems like lithium ion, sodium ion, they work much more efficiently, especially
so
cycle life
intercalation
is
means
interesting.
you have some host material where the lithium can, as the name says, intercalate, so go in between and get stuck, and then be released upon discharging again, correct?
Exactly. I mean, this is exactly the beauty of the technology that was awarded with the Nobel Prize simply because of this concept. Like in electrochemistry, we also have conversion reactions that actually include breaking and building new bonds. Like in a lithium oxygen battery, you bond
So
lithium
you
and
change the
oxygen.
molecule structure rather than just mechanically intercalating the molecules with another?
It's not just mechanically, it's an electrochemical process, but the bonds, of course, are different ones. But let's say if you have this full conversion from one compound to another, it's usually less reversible than the lithium ion battery, which like a kinetically stabilized solid electrolyte interface. And that's the beauty about the technology.
Yes.
And there we know, okay, we have new technologies coming, they are drop-in ready. You need to change cathode and anode chemistries and you go. But that's
so
why
the
we're
production
also...
equipment remains the same?
Yeah, and this back to your production point for solid state, this is where we need to make some changes because the processing of the solid electrolyte requires different machines, a different layout of the factory. We are aware of these changes and also tell our clients how to get ready for this if they are planning to produce solid state. But you need to stay flexible in this zoo of cell chemistries that, you know, in case a solid state cannot be industrialized because maybe the long-term cycle performance or the impedance is not living up to the quality standards, you might want to still take the route conventional technology and, you know, keep that factory space for maybe a longer coating machine. And
Okay. In terms of cost comparison, so you just mentioned we try to leapfrog and or at least to pick up in Europe and the US to the Asian competitors. Where are we in comparison? So what does it cost to build a cell in China and what does it cost here?
yeah,
Ballpark, of course.
good one. I think first we are behind in terms of technology development, looking at the product technology. I would say 2 to 3 years is reasonable. The question is, will Europe and America catch up on this? You know, with the way the information flows and the R&D we're doing and funding, especially in Germany, which is at stake at the moment. In terms of production cost, look at what you need to invest in setting up a gigafactory. The benchmarks that are recognized at the moment are like $100 million / euros for gigawatt hour in the Western world. Half of that capex investment you need in
gigawatt hour
Asia.
production capacity per year.
Exactly, nameplate capacity. And
yes.
And now, if you map this on the production cost, of course, taking into account labor cost, energy cost, we are not blessed with very favorable conditions, especially in Germany at the moment. So for us, it will be naturally more expensive to produce these batteries. And that's an effect that the upcoming years will tell. Will the European or Western cell production be competitive? In terms of prices, maybe not. That's why we are looking for other differentiators like sustainability, ethically sourced materials, and maybe workarounds like leapfrog
so that we
technologies.
can bring more value to the product rather than just decreasing the costs.
Yeah, it's basically a simple market strategy consideration. Like we have the cost leaders, let's say the top tier 6 Asian cell makers, and they want to keep their cost leader position no matter what. So they know we need to control the upstream supply chains, we need to scale up massively to win these market shares in the future of these 7 terawatt hours. So Europe could be forced into a niche, but that niche could be differentiated by cell chemistry or not by price usually, but then also be very application specific. But if the application is a mainstream electric vehicle, then probably the Chinese batteries will or are cheaper at the moment and will remain cheaper in the future.
Can you give us an estimation, like what the current Chinese battery costs at cell level in comparison to the European and US ones?
Current reports indicate, and with the overcapacities in China and the price war beginning in this year, $55 per kilowatt hour for LFP seems to be quite reasonable. Also, given the material fluctuations, you never know how much did they actually end up paying to produce this battery. But now the techno-economic dynamics are taking effect, especially bidding and pricing strategies to also sell batteries to a foreign market.
Okay.
And the question is, for which price will they sell to Europe? Because we're in need for batteries. We need these products.
So that is the Chinese price at 55 per LFP. Can you state something about NMC? How those compare from the Asian market?
Of course, more expensive. I'm not too profound on that number. I think we're somewhere in the 60, 70 range. Depends on the stoichiometry, of course, but.
Okay, and about the European prices?
Higher. It's hard to get like reliable numbers on this because it depends on the scale that you're procuring the batteries. It depends on your negotiation power with these global cell manufacturers. And if you have, let's say, less than 10 gigawatt hours demand, like a leading company might not take you serious and give you prices that are a bit higher. So good markups, good margins for them, but bad for Europe, of course.
All right. So I think as a resume, quite challenging times ahead. Market is growing. The European battery market can exist in the future, but we really have to find our business case still, where we can deliver unique value that goes beyond price. Correct?
I agree, and in my opinion, we should not lose the momentum. We're slowing down at the moment. It's still a growth story after all, let's not forget this, but we need to defend our position and keep innovating, especially on the product level, in order to stay remotely competitive with the global trend that we're seeing.